We've looked at the triangle proportionality theorem, and we have considered the converse of the triangle proportionality theorem. And now we're going to review the triangle midsegment theorem, which states a midsegment of a triangle is parallel to one side of that triangle, and the length, we're talking about of the midsegment, is 1/2 the length of that side. So let's look at this diagram that we have here. So JK, we can determine that JK is a midsegment of both FH and GH. And we can see that by the congruency. So it's a midsegment. It's bisecting. We've got a midpoint here at J between F and H because we got two congruency marks. We also have a midpoint here at K because we see the congruency marks here for HK and KG. And that would mean that JK is parallel to FG. And that being the case, since JK is parallel to FG, then JK is 1/2 of the length of FG. So if our parallel line that's inside the triangle, connected to two sides, is parallel to the third side, and that segment, in this case JK, is a midsegment of both the other two sides, then JK would be 1/2 the length of FG. So we can use that plus the concept of parallelism, parallel lines, to find some measures within a triangle, and I believe that's what we're getting ready to do right now. All right, so we have here this triangle ABC, we'll say ABC, and then we've got a couple of lines inside of that larger triangle. Now, we can determine here from looking at this that FE, well, that forms a midsegment between AC and BC by these congruency statements here. So FE is a midsegment, which means it must be parallel then to AB. And then we can also determine here that ED, well, it forms a midsegment. It's a midsegment of AB. I can see those little congruency marks there, and BC. All right, so it must be parallel to AC. All right, okay, let's see what we got. So find each measure. Find the measure of DE. So we're wanting to find the measure of DE right here. All right, so let's see. Since DE is is a midsegment between AB and BC, then it must be parallel then to AC, which means that DE is going to be 1/2 the length of 15, and 1/2 of 15, so let's see, DE equals, let's do it like this, 1/2 of AC, and AC, we're told, is 15, and so 1/2 of 15 is 7.5. All right, no, it's not too bad. All right, what about DB? DB is right here. We want to find the measure of this. All right, well, this is kind of using the converse of that, isn't it? Because FE, I see here that FE, what kind of color can we put this in? FE is a mid-segment between AC and CB, all right, which means that FE must be half as long as AB, and here we see that these two segments are congruent. So if 9.2 is half as long as AB, then AB must be equal to 18.4. And AD and DB are congruent, which means that they're going to be half the length of A4, 18.4. So DB must then equal to 9.2. All right, hope you followed that. All right, let's see. Now we got an angle measure. The angle measure of FED. So we're talking about this we're talking about this angle right here. And the only angle measure that we know is here at, let's say, BDE. That's 82. All right, so let's look at the relationship here. What would be the relationship between FED and BDE? Okay. All right, so AB is parallel to FE. And DE is parallel to AF. Okay, FE. Oh, no wonder I'm not seeing it. I've got the wrong angle measure. FED's right here. FED's right here. Okay, well that sure helps. All right, so if FE is parallel to AB, and we've shown that through the mid-segment theorem, then ED is a transversal. ED is a transversal of FE and AB. And if that's the case, these are alternate interior angles. DBE and FED are alternate interior angles, and so they're going to be congruent. Well, then FED must be 82 degrees. Wow, I had to think about that. Well, I had to correct my mistake to be able to think about that. Otherwise, I didn't see it. Because you know what? It wouldn't have been there. Okay. So, FED and BDE are alternate interior angles of the two parallel lines, FE and AB, where ED is the transversal. Triangle midsegment theorem makes you think. What is geometry mostly about? Thinking.